Okay, so this video is split into two because it got a little too long, but we're going to finish off example 6 from the very beginning. It says find the volume of a solid generated by revolving the region bounded by y equals x squared, y equals 0, and x equals 2 about the line x equals 3. So we're going to draw a picture. So y equals x squared is a parabola. Y equals 0, of course, is the x-axis. And x equals 2, we'll say is right here. X equals 2. And so this is the area bounded by the parabola y equals 0 and x equals 2. However, we're going to now create volume by rotating it about x equals 3. So we're going to take this kind of weird shape and we are going to rotate it around the x equals 3 line. So we need to figure out first off where this point of intersection is. Which you could just plug in and you get that that is 2, 4, right? And then the next thing we have to do is, because we are rotating this about x equals 3, we are going to create a horizontal slice, which now will create, if you can picture, a washer. So we need to figure out if we're going to stack this washer, what is the outside and what is the inside. So now in the past we've been using the y-axis and we've been looking further out. But what you need to do is figure out what the radius is from the x equals 3. So I'm going to use a different color here, sorry. Let's use black here. So you have something going from here to here, and then you have something going from here to here. So you can see that what the outer radius actually is. However, first things first, we need to have this parabola into x equals form. So if y equals x squared, the square root plus or minus equals x. But I can reject the negative because I know I'm in the first quadrant. So from here to here, just so you know, that is the square root of y. But we need to know from x equals 3, it's hard to show on a video, but we need to know this part. So this whole thing from here to here is 3, and from here to that curve is square root of y. So this leftover spot right here would be 3 minus the square root of y. So that means my big radii is 3 minus the square root of y. So r squared would then be 9 minus 6 root y plus y. And if I do the same thing for the small radii, does everybody see that although it's x equals 2, x equals 2 is from here to here, and from here to here is 3, so, you know, this is 1. It's not that hard, because you can just, inspection, you can see it's 1. So the radius, the little radius is 1, so little radius squared would be also 1. So now I can set this up. The volume is pi, and we are doing horizontal stacks. If I stack it from here to here, does everybody see I'm going from 0 to 4? So I'm stacking from 0 to 4, and I'm taking my big radius, which is 9 minus 6 root y plus y, and I'm subtracting my small radius, which is 1 dy. So this is pi, and this is going to be, I'm going to simplify this actually before. So this is going to be pi from 0 to 4 of y minus 6 square root y plus 8 dy. So this is going to be y times 1/2 y squared minus, if I add a 1 to a half, I get 3 over 2. So this is y to the power 3 over 2. And then I got to multiply the reciprocal, which is 2/3 times 6. And that gives me 4. And then 8y. And this is from 0 to 4. So after we put all the numbers in, we get 8 pi. All right. So next example, we're going to do this a couple of different ways, the same basic picture, but then we're just rotating it a different way. So the first one is find the volume of the solid when the region bounded by y equals x squared. So we're going to draw a picture. Y equals x squared. Y equals 4. This is my y equals 4. And x equals 0. So, and this is x equals 0, of course. So this is what I'm talking about, the bounded area that we're going to rotate, and we're going to rotate it around the y-axis. So I'm going to use a different color. We're going to take this and rotate it around there. So if I'm rotating it around there, can you picture which way I'm stacking? I'm stacking with a thickness of dy. So again, I need to solve for y for my first, and you probably already know by now that x equals the square root of y from the previous example. So if we're stacking, what's this height? Well, by pure inspections, it's 4. What's the low height? Well, that's 0. So we're going to be stacking from 0 to 4. And we're not, it's not two things we're subtracting because there's not a, like this is not a washer, right? So there's no two things I have to subtract. So this is just going to be a disk from 0 to 4 of square root of y squared dy, which would be pi from 0 to 4 of y dy. So for speed, I'll just give you the answer, 8 pi. Next one, same diagram, so I will set it up. Here's the parabola. Here's the y equals 4. Here's the x equals 0. And here's the area. But this time we're rotating around the x-axis. So is this a disk or a washer? Well, there's no space, so we don't have to subtract. And here is my radius like this. So oh, maybe I need to think about this for a second. If I rotate it that way, if I think about, I shouldn't have made my slice here. If I rotate it right here, you can see this is an actual washer situation. So I'm going to use a different color. What is my outer radius? My outer radius is going to be equals 4 my inner radius is going to be x squared. So little r is x squared. So this volume is pi, and I'm going, this time I'm stacking this way from 0 to 2. Remember the intersection was 2, 4. So I'm going from 0 to 2 because I'm stacking this way, right? So from 0 to 2, and it's going to be the outer squared, which would be 16 minus the inner, which is x squared squared. So that's going to be x to the power 4, and that is dx. So we could probably do this by hand, but anyways, first for time, 128 over 5 pi. You can do that for practice. Okay, and then the last one is, again, the same diagram. Y equals x squared. Y equals 4. And then we have x equals 0. But we're rotating it about the y equals -2 line. Ooh. So we're taking this and we're rotating it like that. So how are we stacking it? Well, we'd be stacking it like this. And this one is pretty noticeable that it is a washer, right? So again, this is relative to the -2. So my big R is going to be that length, which by just looking at it, you can see that that is 6, which means R squared is 36, right? And then if I try to find my inner radius here, that is going to be, so sorry, I should maybe do it here so you can see it a little bit better. There's my lower inner radius. So that is using the x squared, but the x squared is only up to 0. So do you see we have this additional 2? So do you see my little radius then would be 2 plus x squared, which would mean my r squared would be 4 plus 4x plus x to the power, sorry, 4x squared plus x to the power 4. So then I'll put it all together. My volume is pi. I'm stacking this way. So I'm going from 0 to 2 because I'm stacking this way. So 0 to 2. And this is my big radius, which is 36. Subtract the little radius, which is this whole thing. So I'm just going to make everything negative there. So subtract 4x squared, subtract x to the power 4, and that's dx. I'm going to simplify. Volume equals pi from 0 to 2 of negative x to the power 4 minus 4x squared plus 32 dx. And again, for time, I'll give you the answer. It's 704 pi over 15. So again, drawing the picture will help, and trying to analyze it all. I think at this point we're pretty good at the definite integrals. We just need to make sure that we know how to set up the integral.